Today we will finish up this 4.4, the graphing log functions, and then we'll finish up 4.5 and hopefully 4.6 before you leave for spring break. Now, for graphing log functions, I will start with the basic idea that basic log functions, like fx equals to log base a of x, is the inverse of gx equals to a to the x. They are inverses to each other. So the way we graph log function will rely on what we know about exponential function. Now, for example, for base a greater than 1. Now we know the graph will look like this for exponential function. That's what the graph looks like. It is increasing. Now then, the log function will be the reflection of that graph with respect to this line, y equals to x. Okay, maybe I move it to the middle. So for a greater than 1, now this is our a to the x. Now when we reflect that with respect to y equals to x, then the log function will look like this. Okay, basically we reflect that with respect to y equals to x. So this point becomes here. This point becomes here. You see? Now then, consequently, then the domain of exponential function, which is all real numbers, will later on becomes the range of log function, which is all real numbers. Because they are inverse to each other, right? You remember, like if two functions are inverse to each other, then the domain of one function is the range of the inverse. And the range of the function, which is from 0 to infinity, will become the domain of the function, of the inverse function. So basically, we are saying that this guy here has to be strictly positive. The argument of log has to be strictly positive, which we have seen from Tuesday. Furthermore, in exponential function, the y-intercept is 0, 1. Now, in logarithmic function, that y-intercept becomes x-intercept. While the x-intercept in exponential function, which is known, will give us y-intercept known in logarithmic function. Now, I believe you have seen this in my lecture also, but I repeat that here because it is a very, very important foundation. Horizontal asymptote. Horizontal asymptote for exponential function is y equals to 0. That becomes the vertical asymptote, x equals to 0 in logarithmic form. Okay, in fact, let's see this one. Let's see this one. Okay, as x goes to negative infinity, fx, I'm sorry, this one is gx. Gx will go to gx will go to 0. As you go very, very far to the left on the exponential function, the value of the function gets closer to 0. Now, how do we express that in log form? In log form, as x approaching 0 from the positive side, approaching 0 from the positive side, the function approaches negative infinity. Okay, that's the parallel. That's the parallel. That's the parallel among these two. Okay. Now, when the base is between 0 to 1, if the base is between 0 to 1, for a between 0 to 1, notice that it will be a decreasing function. Okay, therefore, the reflection of that will be something look like this. Basically, again, this point becomes here. This horizontal asymptote becomes this vertical asymptote. Okay, everything else are the same. Everything else are the same. That is that as x goes to positive infinity for the exponential function, the graph of the function will, the value of the function will approach 0. And the parallel in log with base between 0 to 1, as x goes to positive 0, like 0, approaching 0 from the positive side, from the right-hand side, then the function goes to infinity. Okay, but one thing is being maintained. One thing being maintained, that if the base is greater than 1, both of them increasing. Well, actually, if a one-to-one function is increasing, the inverse will also be increasing. If a one-to-one function is decreasing, the inverse will also be decreasing. Okay, now that becomes one of the key steps in one tricky question that I may show you somewhere in future. Now, let's apply this into log functions. I believe in my lecture I did log base 2. That's a standard approach when we barely start teaching. Okay, now let's start using log base 3 instead. So example 1, can we graph log base 3? Y equals to log base 3 of x. So what you need to imagine is the graph of y equals to 3 to the x. The graph of log 3 to the x, the y-intercept is 0, 1. The other two important coordinates, 1, 3, and -1, 1/3. No, give me a second. Yeah, that's what it looks like. So this is a to the x. The black one here is a to the x. And this one here is log base a of x. Okay, we'll graph that one also later on. Yeah, but let's start with log base 3 of x. Log base 3 of x looks like we start from 3 to the x, and then let's graph that. Log base 3 of x. So we start with this. The way we think is this. Okay, the 3 to the x has 3 important coordinates: 0, 1, 1, 3, negative 1, 1/3. Right? That's what 3 to the x look like. Now reflect that with respect to the y-axis. The y equals to x. So 0, 1 becomes 1, 0. 1, 3 becomes 3, 1. Okay, negative 1, 1/3 becomes 1/3, negative 1. In fact, I can go a bit further. When x equals to 2, the y is 9. So when I revert that, becomes 9, comma 2. So that's what the log base 3 look like. Y equals to log base 3 of x. So one of the coordinate here is 9, comma 2, which came from up there, 2, comma 9. Is it okay? Now that's log base 3 of x. Now how about example 1b? How about y equals to log base 1/3 of x? Log base 1/3 of x. Give me a second. Let me modify my graph. My graphing paper. Now, log base 1/3 of x comes from y equals to 1/3 to the x. So it looks like this. Now, actually, you can see this as this one, 3 to the negative x. Can you see that? That's the reflection of 3 to the x with respect to y-axis. You see? Okay, so the graph of 1/3 to the x looks like this. You reflect 3 to the x with respect to the y-axis, right? Okay, so this is 1/3 to the x. Now then, what is log base 1/3 of x? 0, 1 becomes 1, 0. Negative 1, 3 becomes 3, negative 1. Here, so then we have this graph here. 3, 3, 3, 9, 2. Okay, so it looks like this. That's what it looks like. Okay, it's quite short because the base is 3. Usually we use base of 2 so that we can see more, but this one is too sharp. Question number 39 in our textbook use base 4, so it's a lot sharper. So it's basically like this later on. If you use base 4 or base 5 or base 10, you know, it's way too sharp, such that we don't have really a chance to see more details on those. Now, based on these two log function, log base 3 of x, then let's take a look on what will that look like if we do the following. For example, let fx be log base 3 of x plus 3 minus 2. If we have log base 3 of x plus 3 minus 2, we start from the domain. We start from the domain. Part A, what's the domain? Now, the original domain for log base x is from 0 to infinity, right? Okay, now then for this graph, we will move 3 units to the left. And then we move 2 units down. Okay, now then the domain, as you can see, will be from -3 to infinity, which you can also see in the following way, a better way, in my opinion. We see it this way, that the argument has to be positive, strictly positive, not even 0. So x is greater than -3. Okay, that's for the domain. Now, how about the range? The range for the original log function is all real numbers, such that when I move it down to the left 3 units, that's the same. Move it down, it's still the same. How about the y-intercept? As you can see, now we have y-intercept. Right? We have a y-intercept here. Okay, now how to find the y-intercept? Just like before, we compute f0. That's log base 3 of 3 minus 2. Now, what is log base 3 of 3? 3 to what power equals to 3? 1, that's right. Log. If you have hard time to compute that, don't attack your calculator right away. Actually, your calculator cannot do this yet. Okay, not yet. I will need to teach you how to use calculator for this. But log base 3 of 3 equals to what? Call that x, and then change that into exponential form. 3 to the x equals to 3. 3 to the x equals to 3. Then solve for x. Remember that now? Okay. If you don't get used to it yet, then that's what you do. Okay. Which you're supposed to get used to it already though. But I know some intermediate algebra teacher, they don't do a good job there. So 1 minus 2 equals to -1. So the y-intercept is 0, -1. Now, how about the x-intercept? X-intercept, you set the y equals 0. So 0 equals to log base 3 of x plus 3 minus 2. 2 equals to log base 3 of x plus 3. And then I change it into exponential form. Log 3 to 3 squared is x plus 3. Right? I change from log becomes exponential form. So 9 equals to x plus 3, 6 equals to x. So the x-intercept will be 6, 0. Now, how about the vertical asymptote? The vertical asymptote will be x equals to -3. Originally, x equals to 0. Originally, x equals to 0. So originally, the vertical asymptote is here, right? When you move it 3 units to the left, it becomes x equals to -3. Now, that's one way to look at the vertical asymptote. Another way to look at the vertical asymptote is this one here. Take a look on what makes this argument equals to 0. Take a look on what makes the argument equals to 0. Okay, and the surrounding, of course, has to be positive. then let's start graphing this. The x-intercept, the y-intercept 0, -1, x-intercept 6, 0, vertical asymptote x equals to -3. But don't forget, you need to account for 3 important coordinates. Those 3 important coordinates were 1, 0, 3, 1, 1/3, -1. Remember that? Now, move these 3 coordinates here according to the transformation. You move 3 units to the left, 2 units down. So for example, this point here, if I move 3 units to the left and 2 units down, oh, that gives us the y-intercept right now. Okay, so that one is done. Now, how about this guy? 1, 0, 3 units to the left, 2 units down. So 3 units to the left, 2 units down. So this is the new coordinates. And then the last one, 1/3, -1, 3 units to the left, 2 units down will be here. Now this way, then you have even more coordinates, and those coordinates are important coordinates to help us, guiding us to sketch the graph. That's what the graph looks like. Is it okay? What happened if I change, let me modify this question here. How can we find the point? Which point you're talking about? The important coordinates? The one we call important coordinates? That -3. Oh, originally, yeah, originally it was here. Originally that coordinate was here. Let me use, originally that coordinate was here. 1/3, -1. Now then, if you move it 3 units to the left and 2 units down, it will give you that coordinate. Now, is it okay? Now, you may wonder then, where did I get that 1/3, -1? Now, that 1/3, -1 comes from the reflection from the exponential function. So it comes from this one here. This is exponential function 3 to the x, right? Now, when you reflect that, those 3 coordinates with respect to y equals to x, you will get this guy, and this guy. So the reflection of 3 to the x will give us log base 3 of x. Okay, that's where we get those 3 important coordinates. Now then, from the log base 3 of x, we move 3 to the left, 2 units down. Okay. So you see that the storyline is actually quite long already right now. We start from exponential function. Now we make it basic log function. Now we move that log function. So when you move that log function, then you basically move all those important coordinates also. So the shape of that 3 to the x, that exponential function 3 to the x, the shape will be still the same with this shape though. Okay, if you cut this 3 to the x, okay, it will match. You can play around and it will match with this graph. Okay, you need to flip that somewhere. Okay, you need to flip that somewhere. Okay, but it will match. It will match. It feels like this. Have you ever moved to a new place, move your house? This is something quite fun to observe. Have you ever moved to a new place? If you are an immigrant like me, and then there were sometime in your life you actually moved from your hometown to a new place, right? Okay, but when you move to a new place, a lot of things actually looks new. Okay, now I wonder if I ever shared this with you. Give me a second. Move house. Move house. I wonder if they showed it here. No, not this one. Where's that again? This one. This is what I want to show you. In some part of Indonesia, forgive this advertisement. In some part of Indonesia, when we move house, in my hometown, this is one in my hometown. This is what it looks like when you move a house. That's the house, and they move it. Working together, hundreds of people. You better make friends, very good friends with them. Otherwise, they won't do that for you. Okay, now, so imagine our transformation basically moving that thing. Okay, all the coordinates are still the same. And it says that, let me pause this, what it says here. This tradition is usually led by the chief of the tribe, and it's not something you can do just anytime. No, because these people only listen to the chief of the tribe. So make sure you actually have a good term. You are in good term with him or with her. Usually it's him though in Indonesia. And the steps has to be exactly the same, because you just need around 3 or 4 people have different steps, and then this house actually becomes uneven and it fell off. Okay, never seen this, huh? The true meaning of move house. I mean, you move the house. You don't move yourself to a new house. No. They don't even use any wheel though. They actually carry them on their shoulder. Okay. Now, imagine this thing. So for me, it's easier to understand transformation because I have this in mind. In fact, this is coming from my hometown. Okay, this video is from my hometown, but it's not only mine though. There are some tribes actually have this tradition when they move the house, they really move the house. So instead of you move to a new house and the old house get renovated. No, you don't need to renovate anything, especially if the house is good. Okay, now do not underestimate this house though, even though it seems like it's made of wood, right? Okay, but let me tell you that Indonesia is on earthquake place. Like we have earthquake there, a lot of earthquake. So that's why our house, a lot of them actually made of wood. Now the wood, on the other hand, are actually good wood. The one that you use for in America, you use that for electric pole. Those poles can stand for like 60, even 100 years under any weather. Now, so those kind of woods, it's maybe even more expensive than your brick here. You know, so instead of like tearing it down, no, they just move the house. So imagine if you have your house originally look like this, and then being flipped and then being moved. Okay. So again, for me, it's easier to understand because I saw that before. Now I use that as an illustration right now to have you seen that, hey, you know what? It is possible you can move your house, literally move your house, such that the next morning you wake up, you still feel the same in your own room that you live in the last how many years, right? It feels like that. Okay. Now, what happened if then, another example, let's call this example 2. Let fx equals to log base, let me make it base 2 right now. Okay, log base 2 of 4 minus x minus, maybe minus 3. Yeah, let's do this one. Let's do this one. We start from log base 2 of x. Log base 2 of x. So you imagine this on your scratch paper. Log base 2 of x looks like this. And then we will move 4 units to the left, replacing x by x plus 4. So you move 4 units to the left. That's what it looks like. Okay, now then replace x by negative x. Replace x by negative x. When you replace x by negative x, you reflect the graph with respect to the y-axis. So now the graph looks like this. And then you move down 4 units, 3 units, I mean. So maybe it looks like this now. Okay, basically, you move it down. Basically, you move it down. I guess later on, it should look like this, but you don't need to be super accurate for this though. Yeah. Okay, now let's start with then the question of the domain. What's the domain? Remember, the argument of a log has to be strictly positive. In other words, 4 minus x has to be strictly positive. So the domain is from negative infinity up to 4. The range, however, originally all real numbers, now stays all real numbers. Okay, and then part C, how about the y-intercept? F0 equals to log base 2 of 4 minus 3. What is log base 2 of 4? Two to what power equals to 4? That's 2, right? Okay, so the y-intercept is 0, negative 1. And then how about the x-intercept? Let me do it here. 0 equals to log base 2 of 4 minus x minus 3. 3 equals log base 2 of 4 minus x. Now change it to exponential form. 2 to the power of 3 equals to 4 minus x. 8 equals to 4 minus x. So x is negative 4. That's right. So x-intercept is negative 4, 0. Now the vertical asymptote, let me do it here. Vertical asymptote, as we can see in our sketch there, it's x equals to 4. Okay, now then, let's put them together. The y-intercept is 0, -1. Here, x-intercept is -4, 0 here. And then the vertical asymptote is x equals to 4. Okay, so we know the graph later on will look approximately like this. Okay, now the thing is, again, we need to get those 3 important coordinates, where they are. Okay, where they are now, those 3 important coordinates. Now, originally, that's base 2, right? Log base 2 of x has these 3 important coordinates, this guy, and this guy. Now, you move 4 units to the left, so those 3 important coordinates becomes like this, right? That's 4 units to the left. And then reflect with respect to y-axis. This point becomes here, this point becomes here, this point becomes here. And then from there, we move down 3 units. So this point becomes here, this point becomes here, this point becomes here. Let me bubble it thicker. Now those are the 3 important coordinates. Okay, now then let me connect the dots. That's the graph. Okay. Now you will see in our exercise later on, my old test especially, you will see problems like this, like the transformation thing with logs. Now let's deal with some strange stuff right now. Stuff that is the type of graphing that I will not ask in my test. But good to know, good to imagine. For example, the graph of y equals to log base 2 of absolute of x. How do we deal with the graph of a function that contains absolute of x? Now think of it this way. From the past, we know absolute of x is equal to x itself when x is at least 0, and negative x when x is less than 0. Now, then we will modify this function, y equals to log base 2 of absolute x, now becomes a piecewise defined function, log base 2 of x when x is greater or equals to 0, and log base 2 of negative x when x is negative. Okay, now then, then we can start sketching it. Okay, on the right hand side, on the positive side, when x greater or equals to 0, we will graph log base 2. Log base 2 looks like this. Yeah, let me bubble the important coordinates, the coordinates I use to graph. That's log base 2 of x. Now then, how about log base 2 of negative x? Part of top, just a second, the one here, this one. Okay, now that's for log base 2 of x, this one here. How about log base 2 of negative x? Now that's just reflection of log base 2 of x with respect to y-axis. So to graph this part here, I replace this x by negative x, is right? But replacing x by negative x, replacing x by negative x basically reflect the whole graph with respect to y-axis. So you can copy those important coordinates, reflect that with respect to the y-axis. So this is the graph of log base 2 of negative x. Okay, this is log base 2 of negative x. Now together, this blue one and red one together give us log base 2 of absolute of x. Okay, and it at least we see one thing to connect with what we learned. We see one thing. What is the domain of this log function now? Well, the domain will be, let me use blue instead. The domain will be when absolute of x is always greater than 0. Right? But absolute of x is always greater or equals to 0. So the only time it doesn't satisfy is when absolute of x is not equals to 0. That's when x is not 0. So the domain will be all real numbers except 0. Right? Which is confirmed by our graph, that every x has a value y except when x equals to 0. Okay, now that's for the log function, the graph of log function. I believe from our lesson you see which are your suggested homework to do. Let's go on with 4.5. Properties of logs. As a reminder, basic property. The first one, log base. Oh, you know what? I need to say first, what is the base? Basic properties for a positive and not equals to 1. For the base greater than 0 has to be positive and not equals to 1. The basic properties. First one, log base a of 1 is equals to 0. A to the 0 equals to 1. The second one, log base a of a is equals to 1. A to the 1 is a. The third one, log base a of a to the n is equals to n. Now, if you think about it, the third basic property here is the general case of the first two, right? Because you can write 1 as a to the 0, and you can write a as a to the 1, right? So basic property number 3 is actually the general case of basic properties 1 and 2. Now the fourth one, that's a to the power of log base a of n is equals to n. Now, property number 3 and 4 basically saying exponential function, a log is the inverse of exponential, and exponential is the inverse of log. Log cancels the exponential cancels the log. But of course, with the rule that the argument has to be positive. Okay, the argument has to be positive. Maybe I write it there, that the n has to be positive. And the last one, which I didn't write in the past, is that domain of log is positive argument. In other words, log base a of star can only work when that star is strictly positive. Now, do not underestimate this last property here. I believe I emphasized that also in my lecture, but that is being used to solve the following question. Find the domain of fx equals to, let's say, log base 7 of x squared minus 4 over x squared minus 3. Find the domain of that log function. You never see this question in our textbook, even though it is in our West LA College textbook. And the domain of log is that the argument is positive. So what you need to solve basically this x squared minus 4 over x squared minus 3 is strictly greater than 0. That's all you need to solve. Okay, and then it's already it's a rational non-inequality, right? Okay, it's already one fraction and the other side already 0, so I can start the procedure, the critical numbers, okay, which I insist you have to use in my test. Okay, so you will see the critical numbers on the top. Actually, x equals to 2, x equals to -2. At the bottom, the critical numbers are x equals radical 3 and x equals to negative radical 3. In fact, that's an even function, as you can see. Okay, so it will be symmetric with respect to y-axis. Radical 3 and 2. Negative radical 3 and 2. That's the sign graph. I do it fast. You can confirm later on. I just show you that what we learned before with that inequality is very useful in finding the domain. Now, but to solve an inequality which is not linear and not absolute value, you need to go through these 3 steps here. Okay, if there's easier way, I would have shown you, but no, I don't find any easier way. I have not find any easier way. Okay, so the solution will be, then it will be from -infinity to -2 union negative radical 3 to radical 3 union 2 to infinity. It has to be strictly positive. Now, the work that we do in this example solely rely on, from the log part, solely rely on that fact. Okay, now how to execute that, we learned that from chapter 1, solving nonlinear inequality. Or maybe chapter 2, I don't remember precisely. Okay. Those are the basic properties of logs. Now then, what are not so basic properties? Again, for positive A, for the base positive and the base is not 1. Okay, and the X and Y also positive, we have the following. First one, log base A of product equals to log base A of X plus log base A of Y. Log of product equals to sum of log. When we multiply the same base, we will add the exponents. The second basic property, log base A of quotient equals to difference of logs. Okay, and the third properties will be log base A of x to the, let's say x to the b equals to b times log base A of x. Now, I don't really emphasize on proving in this course. I don't think I will ever ask you to prove, even though when you do the work, more or less you need to know some facts to prove. Okay, but I strongly recommend you, please watch again the proof in my lecture. I believe in my lecture video, I show you the proof of these three properties. Okay, now we will use these properties to break down complex logs or to combine sum or difference of logs. Let's start with question number 3 in our textbook. 4.5, number 3. Give me a second. Log base A of, I use parentheses here, x cubed w over y squared c to the 4th. I will do it slowly first, and then the second time I do this, I will do it faster. Okay, you have seen in my lecture how to do it fast also. Okay, but just to remind us, okay, we will see this as log blah over log blay. I mean log blah over blay, which then becomes, using property number 2, that's log base A of x cubed w minus log base A of y squared c to the 4th. Now then, for each of them, we have product, right? So I will use rule number 1. So property number 1, this will be log base A of x cubed plus log base A of w minus log base a of y squared plus log base a of c to the fourth. Okay, now it is necessary for you to use parentheses here, especially because this is what it breaks down to be. Okay, now without that parentheses, take a look. Without that parentheses, then your coefficient of log base a of c to the fourth will be positive. Why is it supposed to be negative? Oh, let me distribute the negative now. So this is log base a of x cubed plus log base a of w minus log base a of y squared plus, I'm sorry, minus log base a of c to the fourth. And then the last step, I will use step 3, property number 3, in which I will bring the exponent of the argument to the front. Log 3 log base a of x plus log base a of w minus 2 log base a of y minus 4 log base a of z. Now, what I want you to pay attention to is the following. Let me erase some part of this. What I want you to see is the following important one. Now, notice that as long as it is on the numerator, then the coefficient of that log will be positive if it is on the numerator. If it is on the denominator, then the coefficient of that log will be negative. Okay, in fact, furthermore, we can say that the coefficient of that log is equal to the exponent. W to the 1, so that's 1, positive 1, right? Y squared on the denominator, then the coefficient is negative 2 for that log base a of y. And c to the fourth is on the denominator, then it is negative 4 for that log base a of z. Okay, so in other words, I do expect you at this level to be able to break down these questions here into sum or difference of logs in one step. Okay, so I do expect you to look at that question and say, oh, this is equals to, let me deal with the x first, 3 log base a of x plus log base a of w. Okay. Oh, y squared is at the bottom, so it will be minus 2 log base a of y. C to the 4 on the denominator, so negative 4 log base a of c. Okay. Otherwise, then it will take you too much time. Yeah, otherwise it will take you too much time. Unnecessarily, you know, unnecessarily. If you have good understanding, you will be able to do it fast. And the fact that you cannot do it that fast, very likely because you don't have full understanding. So that's why I insist on speed. Okay, that's why I insist on speed. Let me explain a little bit more about me. Now, most of you, I mentioned many times that I come from Indonesia, right? Okay, I come from Indonesia. Now, Indonesia is a very big country. You can say it's as big as America. We have slightly less number of people in Indonesia compared to America. So this population size pretty much, you can say, quite equivalent. Okay, so education there, of course, is not as advanced compared to here because we are, well, in the last 3 decades, we can consider ourselves as developing country, but not developed country yet, like America. Okay. However, Indonesia is next to Singapore. Indonesia is next to Singapore, and Singapore is best known as their Singaporean math. Singaporean math, actually, they learned that from, mainly, you can say, from England. Okay. But there is a flavor of Indian there. Some little cultural background. So Singaporean math, the orientation actually from England. They were under British colonization for many years. Okay, but before that math influence came to Singapore from England, it actually went through India first. So what is the difference between British and Indian? British England math tends to be proving, a lot of very deep understanding. However, math from India emphasize on speed. Okay, a lot of repetition. Okay, now repetition makes it faster. Of course, you still start with understanding, and then a lot of repetition. So Singaporean math has because they are so good. Okay, now Singaporean math influence Indonesian's way of teaching math. So I'm not saying that what I learned in Indonesia is purely Singaporean math. Okay, well, we were colonialized by Dutch for 350 years. Okay, so Indonesian math is also influenced by Dutch teaching of math. Now, but one of the key ingredients in Singaporean math is that, of course, that you need to understand first. But the one that a lot of American math teacher, well, when they teach math, they want to follow Singaporean math, but they don't really do the second part of Singaporean math, that is on speed. And the third part is frequent quizzes. If this were an actual class, on-campus class, then you will get quiz every day you come to class, in my class. Now, I cannot do frequent quiz anymore right now because I don't want to do that all the time online, but in class, it's a lot easier. Okay, now the quiz is only 10 minutes. Now, I'm saying this because even back in Indonesia, we experienced the same thing. You get quiz every day. Okay, every time you come to class, once you step in, your teacher will greet you with a quiz at hand. She will say good morning while giving you the quiz. Okay, now, of course, in America, that feels like a big pressure that you have quiz every day. But that's also the reason that a lot of you don't do well in your quiz or in your test. You have that test anxiety. Right? Okay, a lot of you experience that. And you think that's because of you have some kind of a psychological problem. But no, I don't want to go to say that you are sick right away just because of you have test anxiety. The fact that you have test anxiety could be, and actually very likely, because you are not being tested enough, not enough experience in taking tests. Now, the reason I explain this is because the following. Remember that on my Monday, Wednesday, I go over previous tests? Now, I want you to practice taking tests and time yourself. Okay. In my when can I get the score for test one? I already done with your grading your tests, but I cannot release yours yet because I still have one person need to take a makeup test. So I will release that the latest on Saturday. The latest on Saturday. Okay, but I'm done with the grading. I'm actually done since last week and was planning to release that last week, but that person supposed to take it last Saturday, and he postponed it again. So I decide, okay, if so, I will release the one from for Monday, Wednesday, the one who took Monday, Wednesday test. Okay, because that person will take different tests and it will be a bit similar to yours. That's why I don't release yours yet. Okay, but for both tests, Monday, Wednesday, and Tuesday, Thursday, I don't release the solution yet. Yeah, I wait until he takes the test. Okay, now anyway, coming back here. Now, a lot of you, when you took the test, you have issue with the time. You feel that, oh, the time becomes a pressure, right? But and you think that's a bad one. But at the same time, you should think that it's because you don't get used to it. Okay, you don't get used to it. The fact that you will need to take a test when you take a class is something have been done in the last century. So having a test anxiety, unless you have some psychological issue that need to because of some background, okay. Like me, I think I told you that I have depression also, right? So it's not a bad thing when I say that you have psychological issue, but before you claim that you have that psychological issue, ask yourself first, is it because I don't have enough practice? Okay, our goal is my goal is not to make you feel good. Okay, my goal is to help you so that you can overcome test anxiety. Because wherever you go after you transfer to UCLA, UC Berkeley, MIT, whatever good school you want to go to, you will always take a test, and the test always be timed. Okay, having a test anxiety right now is something you're supposed to overcome as soon as possible. Okay, and one way to practice is actually put yourself in similar environment when you take a test. When you practice at home, time yourself. Okay, yeah, I'm not saying this to degrade you. I'm telling you that's the type of practice, that's a type of training you're supposed to get. My hope is after you pass this class, you take your calculus class later on, then you can proudly say to your instructor at that time, oh, I passed Thomas' class and the test is hard, but I make it. Okay. There is no pride in telling other people, oh, Thomas is so nice. I didn't pass the test, but he passed me anyway. Will you say that to your children? I passed pre-calculus class because the teacher curved it. No, what kind of, you don't expect that, right? No, there's no pride in passing the class by curve. Okay. And yeah, enable yourself. Okay. Enable yourself. You can do it. Okay. You practice. Okay. Unless you have some issue, but before we say it's because of that, what I call psychological issue, try to find out first if it is really because of that. Okay. Now let's go back. Now, time is quite important because I somehow think I mentioned it in this class or maybe in my other class. How long do you take to compute 5 times 7? Now, when you see 5 times 7 and you say it's equals to 35, how many seconds did you take? 1 second, right? Okay, 1 second. Now, if I tell you somebody needs 1 minute to do 5 times 7, what do you have in mind? Okay, to be honest with you, 5 times 7 is something I take 2 seconds, not 1 second. I cannot do that. I don't think I can do that in 1 second, but 2 seconds, 3 seconds is reasonable. Okay. I think if it takes you 5 seconds, it's still okay. But if you take it, if you tell me, Thomas, I need 1 minute for that, my impression is like, no, you don't know that thing. Okay. Well, I know it. I just need more time. No, you don't know it. Not at this level. You don't need 1 minute for 5 times 7 at this level. Okay. However, you try to insist that on me. No. Okay. I cannot take it. Okay. And nobody in well prepared for pre-calculus will take 1 minute for 5 times 7. Okay. Now, the thing is, it actually also applies for other things. Okay. Nobody compute 5 times 7 and say 35 by doing a fast addition at the back of their mind, 7 plus 7 plus 7 plus 7 plus 7. No, nobody does it. All of us do it by memorizing. All of us do it by memorizing. Okay, nobody, in fact, if when you say 35 and then I ask you, how did you do that? You will get confused. What kind of question is that, Thomas? Nobody ever asked me to explain how I get 35 from 5 times 7, right? Okay, it's like you just need to know it. At this point, there's no more explanation why 5 times 7 equals to 35. No more. You just need to know it. It's so basic that nobody will ask you how you get that anymore, right? Okay, now for this log later on, try to internalize that such that you can do it and the explanation comes later. Okay, for example, number 7. Natural log of 4th root of x to the 7th over y to the 5th times z. There are so many ways to do this. I look at this question, I see at least 4 different ways to do this, but all of them give us the same final answer. Now tell me, what should I write first on the final answer? Seven over 4. Natural log of x. Do you see that? And then minus 5 over 4 natural log of y. Minus 1/4 natural log of z. That's it. Now, if I need to do it a bit longer in 2 steps, let's say, then I take the 1/4 out first, right? So I have 1/4 natural log of x to the 7th over y to the 5th z. That's equals to 1/4 of 7 natural log of x minus 5 natural log of y minus natural log of z. Then distribute that 1/4. You'll get that thing. Thomas, in the test, do you mind me to show all the work instead of just do it in one step? I don't mind. You can show all the steps, but don't blame me if you don't have enough time though. Now, when I ask you this question in my test, like number 7, I will assume you will take the midpoint, like not doing it in one step, but not doing it in way too long also. So somewhere in the middle, like something that you do in this blue color instead. That's the time I approximate you take. So this question will take approximately 3 minutes, 2 minutes, 3 minutes. Even though I give 4 points maybe for this question, okay, but I do expect that you can do it in, on average, around 2 or 3 minutes. Okay, now how about putting things together? Let's start with number 9. number 9, write as a single log. Number 9a, log base 3 of x plus log base 3 of 5y. Sum of logs equals to log of product. So that this one is straightforward. It's 5xy. Part B, log base 3 of 2z minus log base 3 of x. This is log base 3 of 2z over x. Now for part C, 1/5 log base 3 of y. That 1/5 is log base 3 of y to the 1/5. And that's already okay. You know, even though our textbook may want you to write it as a 5th root. Okay. Now let's do number 13, and then I will take a break. See, if it takes you so much time for the basic part, then number 13 will take you too much time. That's my concern. That's my concern. Okay, log of x cubed y squared minus 2 log x cubed root of y minus 3 log x over y. Now, put them together in one single log. That's log of, let's deal with this first. That's positive coefficient, so it should be on the top. That's x cubed y squared. And then this guy, -2 with this, because it's negative coefficient, it will be at the bottom. Okay, there will be x squared, y to the 2/3. And then this guy, -3x over y, that's the reciprocal, right? That will be x cubed at the bottom, y cubed at the top. Now take a look first. Take a look first. This guy is x over y to the power of -3. That is y cubed over x cubed. Now anything after that is simplifying. Okay, everything after from here is simplifying. So that will be log of x cubed y to the 5th over x to the 5th y to the 11th third, which becomes log that's y to the 4/3 on the top over x squared at the bottom. Give me a second. Did I make a mistake somewhere? My bad. At the bottom here, this is not correct. How did I get that? No, this is not correct. Not 11/3. That's 2/3. So 15 minus 2, 13. Okay, so this will be 13 over 3. I guess what happened earlier, I multiplied these two, even though they are different base. Okay, that's for number 13. Let me ask you to try number 15 together with our break time. So So number 15, that is natural log of y cubed plus 1/3 natural log of x to the 9 y to the 6 minus 5 natural log of y. Okay, right now it's 9:21. Let me give you, let's come back at 9:34. Let me start working on this. This is natural log of y cubed, and then the cube root of x to the 9th, y to the 6th over y to the 5th. If you want to simplify this first, go ahead, which honestly I will do. Now then this will be natural log of y cubed x cubed y squared over y to the 5th. Oh, the y to the 5th cancels all the way, huh? So we get natural log of x cubed only. That's for number 15. Now, once we are able to combine into a single log or break the logs into sum of difference, then we are ready to do solving log equations. Now, idea. In solving log equation, we basically break it down into two big techniques. The first one, we try to achieve this one, log base A of blah equals to log base A of blah. So you have log equals log. You try to achieve that one. Then we can use one-to-oneness to claim blah equals to blah. That's the first type. The second type, you try to achieve log base A of blah equals to something without log, like a constant. Okay, now if you have one log on one side and no log on the other side, then you go on to the exponential form. A to the blah equals blah. So if you have log n equals to log equals to log, then you use one-to-oneness. If you have log something equals to no log, then you use exponential. Okay, with one extra note. With one extra note that remember the argument needs to be positive. Okay, so whatever your answer, you always check against the original equation. Okay, against the original equations, and the argument has to be positive. Now, you don't need to check if they are equal. No, you just need to check if the argument is positive. Okay, the argument has to be strictly positive. That's all we need. Now, let's say, for example, we take a look on number 19 first. Number 19, 2 log base 3 of x equals to 3 log base 3 of 5. You have log on left-hand side, log on the other, the right-hand side, then I will proceed with making it into log equals log. Okay, so log blah equals log blah implies blah equals blah. Okay, so x is equals to plus minus square root of 5 cubed, which is plus minus 5 radical 5. Now you have two possible solutions here. 5 radical 5 is one of them. The other one is negative 5 radical 5. Now, then you do visual check. If x is 5 radical 5 here, will that be okay? The argument is positive, so we are fine, right? Okay. However, for this one, the argument is negative, so it is not fine. I have to cancel that. You see what I mean? Let me explain a little bit the way we actually work, the way we actually do this. Okay. The following may not be that easy to understand, but I hope you get it anyway. Okay. Please pay attention here. What is the difference between, I hope this little illustration help you understanding. What is the difference between 2 log base 3 of x and log base 3 of x squared? Now, according to seems like property number 3 that they are the same. Property number 3 says the following: log base a of x to the n equals to n times log base a of x, right? Okay, that's what that property number 3 says. But they have one big rule, the what you call that, the assumption is necessary for x positive. Only when x is positive that these are the same. They are not the same all the time. They are not the same all the time. They are not the same for all x. They are only the same if the x is positive. Okay, now, so what I meant to say is this. If we take a look on this expression here, the domain is x is greater than 0, right? Okay, so x can only be positive. But how about the one here? The domain is x squared to be positive. So the domain is basically all real numbers except 0. Because even when x is negative, when you square it, it becomes positive anyway. Okay, so you see that these two expressions, even though seems like to be equal under property number 3, but a further look tells us that they are actually different because property number 3 has the assumption that x is positive. Okay, so are you saying, Thomas, that when we try to solve an equation with 2 log base 3 of x, are you saying that we cannot do it this way? That's not what I'm saying. That's not what I'm saying. In fact, that's what I did, right? That's what I did. Okay, that's what I did. I'm just saying that when you change from here to here, notice that your domain gets larger. Your domain originally only positive. Now your domain becomes positive or negative. Okay, so you may get extraneous solution by doing so. Now, how to overcome that? How to overcome that extraneous solution? Do the final check. Once you get the solution, you check that against the original equation. Okay, so again, what we did here is we changed this using property number 3. But in this step here, the domain actually gets larger. The change in domain, which implies we may get extraneous solution. Now, to overcome extraneous solution, just do final check at the end. Okay. Now, with that said, at West LA College, they have this kind of question in their textbook. So that was textbook question at West LA College. The following question. Let me use the one that we already have here. Okay, the question was this: solve 2 log base 3 of x equals to log base 3 of x squared. Now, some people say, oh, this is just identity. Some people say this is just identity. The solution will be all real numbers. It is not true. It is true they are identity, but the solution is not all real numbers. The solution will be all real numbers that satisfy the domain. Okay, all real numbers that satisfy the domain. So all real numbers, imagine all real numbers, but it has to satisfy that x is greater than 0. Okay, and it also has to satisfy this, but the intersection of those two domains are 0 to infinity. That's the solution. Does it make sense right now? It seems to be that they are just the basic property, right? But no, the basic properties, they're just one of the property. But the property actually has the prerequisite requirement that the argument has to be positive. Don't forget that one. Okay, now I hope through this example 1, this number 19, the question is actually quite simple, right? I don't think this question is a hard question, but it brings us further into looking at the domain. Okay. To be honest with you, how do we know an instructor is good in teaching pre-calculus and not that good in teaching pre-calculus? I learned this from a senior instructor at Pasadena City College. At PCC, I taught at PCC before, and there were 2 or 3 instructors there that I respect a lot. And I once asked them this question. Pre-calculus has a lot of materials that is basically repetition from what we learned in intermediate algebra. And intermediate algebra has exponential function, logarithmic function, exponential and logarithmic equation. Pre-calculus also have the same thing. Okay, what makes them different? And their answer are all look at the domain. Okay, in intermediate algebra, the emphasis is not as much in the domain, but in pre-calculus, the emphasis is a lot in the domain. That's why in almost all the questions I ask you, every function that I ask you, I always start with what's the domain? What's the domain? What's the domain? It's the context of conversation. Okay, that's what make difference. So we don't just robotically solve a problem like you see this, do this, do this, do this, do this, and forget that we don't have anything in the domain. Okay, that's for number 19, but I emphasize so much on the domain of the functions, and that's what you need to pay attention to. Most mistakes that I have from students in my test, most of them comes from the fact they don't realize their answer is not even in the domain. Okay, let me joke a little bit. Okay, but this is not purely joke. This is real. This happens in my life. This happens in my life. When I was 13 or 14 years old, my mom once asked me this question. And I remember this very well because my parent, of course, apparently they are Asians. Okay, my parents have this this mindset that you don't date anyone using your parents' money. That's my mom's rule. As long as you live under my roof and eat my rice, you don't date anybody's child. Okay. So I was 13, 14 years old when my mom suddenly, out of nowhere, asked me this question. Thomas, what kind of girl you want to date? What kind of girl you want to date? Now, notice that this is a conversation between a mom and a son. Okay, so it's a bit private, personal. Take the positive lesson from this. Okay, there could be some implied negative lesson. Now, then, if you think it's negative, then don't need to adopt it. Okay, I'm just trying to illustrate the power of domain. So I remember this story very well because of this background here. She emphasized to me and my brother that you never date anyone using my money. If you live under my roof and eat my rice, you know, Indonesian, we eat rice, right? If you live under my roof and eat my rice, you don't date anybody's child using my money. No, use your own money. Okay, use your own money. So uh, that's the first premise, right? And all of a sudden, one day on my way to school, she asked me this question, Thomas, what kind of girl you want to date? And I was like, Mom, did you eat a wrong? did you have your medicine yet? You know, that's just the saying, though. It's like, what's wrong with you? Suddenly ask this question. And of course, I think about that for a couple of seconds and I just come up with this answer because I knew my mom was like joking, even though later on I found out she was not joking. I just said, well, I want someone who is smart, kind, rich, smart, kind, rich, and of course, cute. Cute should be number one. That's what I say to her. And my mom just roll her eyes, looking at me and say, oh, come on. Oh, come on. And I was like, Mom, why you asked me that question, so I give you my answer, and why you roll your eyes like my answer is not an answer, you know? I mean, I know you were joking, Mom. My mom said, no, I'm not joking. I'm telling you, I'm asking you a serious question. Okay. And I think I need to ask you this question right now. Okay. When you say you want a smart girl, okay, I give it to you, Thomas, that you may be smart, even though you are not as smart as your parents yet. Okay, so my mom and dad are people who always present themselves as the smarter than the people who are smarter than their kids. Okay, so even though you're smart, Thomas, you think you are smart, that's your own mindset, but you are not smart for us, for parents. Okay, kind, no, you are not kind. You are not kind. You talk back to your parents all the time. No, we are not rich. You are not rich. Even your parents not rich. Imagine you yourself, right? So you are not rich, and your face is random. You are not cute. In other words, the girl you want to date is not in your domain. Okay. She even say this. Okay. There are a lot of kind girls. There are a lot of cute girls, but the one that have both, not as many anymore. And of those kind and cute girls, only some of them actually reach. You know that in real life that if you are rich, you may not be kind, right? Okay, some rich people are kind, but not all of them. So what happened is, just to say that kind, rich, and cute, the domain, it's already so small. It's already so small. There's only a few girls actually kind, rich, and cute. Now, add to that that they need to be smart. Then you have just like one or two girls satisfy your requirement, Thomas. Okay. The worst part is, what makes you think, Thomas, that a kind girl will even look at you? What makes you think a cute girl will even look at you? If those girls has someone to look at, you will not be the first one. And when I heard that, it's like, Mom, this is so degrading. This is so you basically put down my spirit, you know. And my mom then told me her lesson on that day. The lesson that she gave me is this: Thomas, you want to date that kind of girl, be one yourself first. So instead of expecting to date somebody who is smart, kind, rich, and cute, how about you become someone who is smart, kind, rich, and cute? Instead of expecting somebody to love you, how about making yourself lovable first? Now, the reason I remember this for 30 something years, because that's the first time I was struck by this big fact that instead of expecting so much from somebody else, how about you expecting the same from yourself first? And that's the life lesson she gave to me. Okay. Of course, I cannot change my face. I cannot change my face. Okay. But I still can make myself study hard such that I look smart. Until now, I don't consider myself smart. I look smart, and that's good enough. Okay. You don't need to be smart. You just need to look smart to get hired. Right. Okay. And I try myself to be kind to everybody except my students. No, I try to be kind to everyone. Okay. And with you, it seems to be harsh because I want you to learn. In my class, it's not the place for me to date anybody anyway, right? So I don't need to be kind to you. Okay. But I need to prepare you very well for your calculus class. Okay. And I was not weak. I come from very poor family. Okay. But I can work hard, and now I look rich, even though compared to a lot of people, I'm not rich, but I'm happy with my life. You see, instead of expecting so much from someone else, how about expecting the same thing from you first? That's the lesson I get. Okay. So instead of asking too much from someone else who are not in your domain, how about you enlarge your domain first? Before you make that choice, you enlarge your domain first. That's the life lesson I get from my mom. Okay. But Thomas, don't you think it has nothing to do with the example you give us here? Actually, it has a lot to do. Okay. What we do first is we enlarge our domain first, get the solutions, right? Then you choose which one you want to date, right? Okay. If you don't enlarge your domain, you have nobody to date. If you don't enlarge your domain first, you have nobody to date, right? You enlarge your domain first. Then if you have extraneous solution, then you don't date that person. Okay, I use dating here as just as an illustration. Okay, it's not that I tell you this is how you date. No. That illustration only for the purpose of this math. Okay, yeah, and so what we did here is we enlarge our domain first. We end up with two solutions, and you check those solutions against the domain of the original equation. Now let's do more problem. Do you have any problem you would like me to do? I will randomly pick questions from here. Let me do number 25. But let me know if you have more questions you want me to do from this section when it comes to solving equations. Number 25, log base 2 of x plus 7 plus log base 2 of x equals to 3. Now the left-hand side, we have two logs. I can put them together into single log. On the other side, no log. That's a constant. So it seems like I will go on with the second idea here later on. So one side I have log, the other side no log. I will make it into exponential form after this. Okay, so let's do that. On the left-hand side, I make it into a single log, log base 2 of x times x plus 7. That's equals to 3. I'll change that into exponential form. So x squared plus 7x equals to 2 to the power of 3. So notice that from the yellow one to the blue one, I already increased my domain. I already enlarged my domain. What do you mean by enlarge the domain, Thomas? Notice that the one here, x has to be greater than -7 and x has to be positive, right? Okay, now the one here, however, the one here, x can be greater than 0, but also okay if it is less than -7. If x is less than -7, let's say -8, this will be negative, this will be negative, the product will be positive. So it goes back to the domain. Okay, so again, take a look from the yellow color to the blue color. Even though, according to our properties, they are the same, but in between, we actually enlarge the domain. Okay, now we will solve this as usual first. And once we are done, we will check against the domain of the original equation. So we get x equals to -8, x equals to 1. Now when x equals to -8, notice that it will make this part negative and this one also negative in this case, right? So I have to cancel this. How about when x equals to 1? When x equals to 1, I put it in here, that's positive, put it in here, still positive, so x equals to 1 is okay. Now, so far we have two solutions and one of them not applied. Okay, that's not always the case. It is possible you have two solutions and both of them okay. It is also possible you have two solutions and none of them okay. Now, if you have no more questions, no question, let me pick more questions then. Let's take a look on number 31. Solve log of x plus 3 equals to 1 minus log x minus 2. I want to have log on one side and in this case constant on the other side. So let me move that log x minus 2 to the left hand side. Log x plus 3 plus log x minus 2 equals to 1. And sum of log equals to log of product. Now then the base is 10, so this is 10 to the 1, and the left hand side is x plus 3, x minus 2. So I change from log form into exponential form. Then I solve this. I don't think this is factorable. Then I proceed with formulas. Okay, the discriminant is b squared minus 4ac. That's 1 plus 64, that's 65. So the axes are negative b plus minus square root of 65 over 2a. So x1 is negative 1 plus square root of 65 over 2. And x2 is negative 1 minus square root of 65 over 2. Now, this number is approximately 8 something. 8 something minus 1 is 7 something. 7 something divided by 2 is 3.5 or a bit more, greater than 3.5. If I put 3.5 here is positive. If I put 3.5 here is also positive. So the first option is okay. So the first option is okay. How about the second option? Negative 1 minus negative 1 minus square root of 65. So that's approximately negative 1 minus square root of 64, which is 8, right? That's negative 9 over 2. That's approximately negative 4.5. I just am doing estimate. Okay, I'm just doing estimate. Now, negative 4.5, when I plug that in here, is already negative. So it doesn't work. Okay, I have to kick that one out. In fact, even if I put it here, it's still negative. Right? Okay, so I have to reject that part. I need to reject this. Cross it out, not applied. Now that's how you actually show the work, though. You don't just give me this one without showing this and reject that. Okay, you need to show me both and underline the solution that you accept. Okay, and cross out the solution that you don't accept. Okay. Do you have any question that you want me to go over here? Now, if not, then I go on to 4.6. Exponential and logarithmic equation. One extra stuff that I have not taught before is change of base. At least I have not mentioned it. It must be in my lecture, but change of base. That says the following. Log base P of log base A of x is equal to log base P of x over log base P of A. For any P, for any base P positive and not 1. Okay, now, So for example, log base 2 of 5, for example, how do we compute this? You can change that base 2 becomes base 10. You can change it into base E. And you can change it to any other base as long as it is positive and not 1. So log base 8 of 5 over log base 8 of 2. It's okay either way. But we will use either base 10 or base E because that's what we have on our calculator. Because that's what we have from our calculator. On your calculator, if you take a look, yeah, grab your calculator now and take a look. Let me show you mine. My calculator here only have base E and base 10. I think if you have TI-92 or TI-89, then you can have other base. But the thing is, like, those are calculator with graphing. Those are graphing calculator. Okay, even this one is graphing calculator, right? Now, the assumption is you don't use graphing calculator. So you need to, every time you need to compute log with base other than E, base other than 10, you need to show the change of base. Okay, so for example, if, give me a second. Yeah, for example, if we need to compute this one here, for example, how do we compute log base 2 of 5? Then you need to rewrite it into either base 10 or base E. You need to write it this way first, and then you use your calculator. Okay, log 5 close parentheses divided by log 2. 2.32193. And make it into 5 decimal places, 2.32193. Okay, 5 decimal places. Now, we call this the exact solution. These two are exact. Now, this is approximate. Okay, which means it's already rounded to 5 decimal places. Now, how do we use that to solve our equation later on? Let's see, for example, let me grab number 15. This type of question always show up in my test. This type of question. What happens if we have different base? 3 to the x plus 4 equals to 2 to the power of 1 minus 3x. Different base. You have at least 4 different ways to work on this problem. 4 different bases to work on. We can use base 3 or base 2 or base 10 or base E. You can use either one of them. Okay, you can use either one of them. Now, you want to tell me which base you want me to show first? Now, if you want to use base 10 right away, that's because you want to use calculator right away. Okay. Now, if you just want to use the exact solution, you just use base 3 or base 2, either one of them. Okay. Let me use base 3 or base 2 first. Solution. Let me use base 3. So I do it this way. I will do it this way. This is my base. This is my exponent. And this is my argument. Okay, so I see that as exponential form, and I will rewrite that into log form. Log base 3 of 2 to the 1 minus 3x equals to x plus 4. Then, using rule number 3, property number 3, I get 1 minus 3x, the exponent brought to the front. Okay, then I will isolate the x. It is by distributing first log base 3 of 2 minus 3x log base 3 of 2 equals to x plus 4. I'll subtract both sides by 4 and add 3x log base 3 of 2. Now, think of this as just the coefficient of x. Those are the coefficient of x. In other words, I can factor the x on the right-hand side right now. I can factor the x, so I get 1 plus 3 log base 3 of 2. While on the left-hand side, I have log base 3 of 2 minus 4. So x is now equals to log base 3 of 2 minus 4 big over 1 plus 3 log base 3 of 2. Now that is the exact solution. Now then, if you want to make it into approximate solution, then you do change of base. Okay, that's log 2 over log 3 minus 4 big over 1 plus 3 log 2 over log 3. Then rationalize, multiply by the LCD log 3. I will get log 2 minus 4 log 3 over log 3 plus 3 log 2 equals x. Now then, how do I use my calculator to compute that? I will compute the top first. Okay, parentheses. Be very careful when you punch it in. Log 2, close the log 2 parentheses, okay, minus 4 times log 3, close parentheses for the log 3, close parentheses for the grouping on the numerator, divided by open parentheses, we will start the grouping on the denominator. Log 3, close that log 3, plus 3 times log 2, close that log 2. And then close the grouping on the denominator. Boom. Negative 1.16464. That's negative 1.6. No, I'm sorry, negative 1.164 464. Now that is the approximate solution. Okay. Now I have approximately 7 minutes left. Do you have any problem you would like me to do between number 17 to 27? Take a look in your textbook, number 17 to 27. Choose one problem before I let you go to your spring break. And therefore, we finish this section 4.6. Let me do number, oh, I see. Number 26, okay. Number 26, let me do it here. We have 3 times 3 to the x plus 9 times 3 to the negative x equals to 28. This is 3 times 3 to the x plus 9 over 3 to the x equals to 28. Let u equals to 3 to the x. So we will get 3u plus 9 over u plus equals to 28. Now multiply by u. Get 3u squared plus 9 equals to 28u. Now you see that it is actually a quadratic-like equation. 3u squared minus 28u plus 9 equals 0. Do factoring. Minus. So u equals to 1/3, u equals to 9. But our u is 3 to the x, and 1/3 is 3 to the negative 1. So x equals to -1, x equals to 2. The domain of exponential function is all real numbers, so there's no need for me to check. Any else? I still have 4 minutes. Okay, let me do one more problem. I see this from, give me a second. I see this from number 33. I think that one is a bit on creativity side. So x to the square root of log x equals to 10 to the 8. How to do this problem? How to do this problem? I have base 10 there. Let me make it into base 10. In other words, I will make it like this. This is my base 10. This is my exponent. Do I want to do it that way? And this is my argument. Okay, so log base 10 of the argument equals to exponent 8. But this is actually log x, right? For this part here. For this part here, this is just log x, right? That's just log x. Is it right? Okay. And then I bring the exponent to the front. Square root of log x. Is it okay? Now you happen to have the same base log x. Let's call that u for now. Let u equals to log x. Now, you don't have to do this substitution thing, but to help me to see that better, that's square root of u times u equals to 8. Now, that's the same to u to the power of 3/2, right? U to the power of 3/2. Are you okay with this? That's u times square root of u. That's u to the 1 times u to the power of 1/2. Okay, so u is equal to 8 to the power of 2/3. Now, what is 8 to the power of 2/3? That's the cube root of 8 being squared. Is it right? That's 2 squared, which is 4. Now, substitute your u back to log x. If log x equals to 4, then what will x be? Okay. Now that's basically what we have here for this 4.6. I'm done with 4.6, and please still watch lesson 13, okay, which already get into our trigonometry already. That's the beginning of chapter 5. Now here's the thing. I don't have the videos for trigonometry except the first couple sections. So on Monday, when we come back, I will do the, instead of, so what happened in the past was like Tuesday, Thursday, we do discussion. The lecture already there. Up to chapter 4. Okay, so Tuesday, Thursday, we do discussion. Monday, Wednesday, we do problems from all tests. Okay, now, but for trigonometry part, I don't have the lecture. So I will do Monday, Wednesday to be my lecture time. Tuesday, Thursday, still the discussion. Okay, so on Monday, when you come back from your spring break, I will start chapter 5 with the lecture. Okay, with the lecture, which you already have watched. I happen to have that videos though. I think 5.1, 5.2, and 5.3. But I will assume there's not there. Okay, and then Tuesday, Thursday still go on with the discussion. Okay, then that's for today. Have a nice, good spring break.